To sum up what we have learnt in this chapter, so we just started with a plane mirror, that was the first thing. So how the reflection goes along in the plane mirror. Then we started with spherical mirrors. So in spherical mirrors, we have convex and concave, where the aperture is, where the center of curvature, the radius of curvature. We learnt about all these things, right? Then we started with the relation between F and R, right? So we always have F is equal to R by 2, irrespective of whether it's a concave or a convex mirror, right? Then we moved on to mirror formula. So the mirror formula was the relation between U, V and F, right? So we have 1 by U plus 1 by V is equal to 1 by F. That was a mirror formula, right? Then we moved on to linear magnification. So whatever the magnification, that is the ratio of the size of the image to the size of the object. That was the magnification. So under that we have linear magnification M is equal to minus V divided by U. This was the formula, right? Then we moved on to refraction. Till now it was just reflection. Now we moved to refraction. The first very important was Snell's law. Snell's law, what does it tell? It tells that the ratio of sine of angle of incidence to the sine of angle of refraction for any given media it's always constant. That was nothing but mu is equal to sine I by sine R, right? So then we moved on to lateral shift, right? So lateral shift is whenever a ray of light passes through a glass slab or any other material medium, so it undergoes shift in the direction in which it was supposed to go. That was lateral shift, correct? So lateral shift was given by what? T divided by cos of R into sine of I minus R, right? This was a lateral shift formula. Then we moved on to normal shift. Normal shift is if the object is in the denser medium and the light undergoes refraction through a rarer medium, then it feels that the object has moved up. That was normal shift, right? So normal shift, again we derived the formula for normal shift, and then we got to know that mu is equal to real depth by apparent depth, right? Then we moved on to total internal reflection. So total internal reflection is a phenomenon where the light object, or you can say the object, is in the denser medium and the ray of light it bounces back to the medium itself because the angle of incidence is greater than the critical angle, right? Using that we figured out that C or sin C is equal to 1 over mu, or C is equal to sine inverse of 1 by mu, right? So this was all under refraction through a normal surface. The next we moved on to spherical surface, right? So the first thing is the refraction through a spherical surface. Under that, what we figured out was whenever you have mu to be the refractive index, U and V to be the object and image distance, then R being the radius of curvature, then we figured out a minus 1 by U plus mu by V is equal to mu minus 1 by R, right? Or minus mu by U plus 1 by V is equal to 1 minus mu by R. These were the two formulas depending on where the ray of light is, correct? Then we moved on to Lensmaker's formula, one of the most important thing. Lensmaker's formula gives us the relation between the focal length and radius of curvature and the refractive index of the medium, correct? So we have 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. This was Lensmaker's formula, correct? Then we moved on to Lenz equation. Lenz equation was given by minus 1 by U plus 1 by V is equal to 1 over F. Again, this gives the relation between U, V and F, right? So this was based on all spherical surfaces, correct? Then we moved on to prism. Very important, under this minimum deviation. So minimum deviation is a condition where the ray of light inside the prism moves parallel to the base, right? So we have mu is equal to sine of A plus delta m by 2 divided by sine of A by 2. So under the minimum deviation condition, we can figure out what is the refractive index, right? Then for a small prism, what was the deviation? That's what we figured out. So that was given by delta is equal to A into mu minus 1, right? Then we moved on to dispersion. Dispersion is what? The phenomenon in which light splits into its constituent colors, right? So that was dispersion. So under that we have the angular dispersion, which was the difference between maximum deviated to the minimum deviated light ray. So we have delta V minus delta R is equal to A into mu V minus mu R. This was angular dispersion. Then we had dispersive power. Omega is equal to the change in the dispersion or the angular dispersion divided by dispersion which is suffered by the mean light. Mean light was what? Yellow light. So we have omega is equal to delta V minus delta R divided by delta. Correct? So after all the dispersion and scattering and then applications of that, basically rainbow, and then why the sun rays or sun is red in color during sunset and sunrise, all the applications of it, then we moved on to microscope or optical instruments, right? So in microscope, simple and compound. Simple microscope, the magnification was D divided by F, right? Where D is the image distance and F is the focal length of the lens. So then we move on to compound microscope, correct? So in compound microscope, you have two lenses, objective lens and eyepiece, then where we keep the object and where the image will be formed. So the magnification was given by minus L divided by F naught into 1 plus D divided by Fe, right? So this was the given formula for compound microscope. Then we moved on to different types of telescopes, reflecting telescopes, refracting telescopes, right? So under the refracting telescopes, you guys learned about only one type, that is the Galilean type of telescope, where again you have an objective lens and an eyepiece, right? So here also the object is at infinity and where the image will be formed, right? So again we learned the magnification of that. So that magnification was m is equal to minus f naught by fe into 1 plus fe divided by d, right? So this was the magnification of a telescope. So whatever we have covered in this entire chapter is summarized in this. So make sure you learn this optics chapter very well, because this has a lot of weightage in the final exam. Alright, so go through the sums, go through the formulas and go through the derivation. So make sure you're comfortable with the chapter.